Okay, so this video I'm hoping is going to show you the relationship between the alpha level and confidence level of a confidence interval, show you how that works a little bit. This is to answer a question that was on the discussion board. Now, the first thing I want to talk about is just a quick review of the alternative is going to show you if it's a one-tail test or a two-tail test. And that's important when you're looking at alpha level and thinking about the confidence intervals together. The first thing you need to think about, okay, is what your alternative symbol is. If your alternative symbol is less than, it's going to be a left tail test. Greater than is a right tail test. And the not equal to is going to be the two tail test. Now, for each one of these, the alpha level is in the tail. That's the reject area. So that's where our alpha is going to be on the left-hand side. Alpha is on the right-hand side. And for the not equal to, we're going to split our alpha. Alpha divided by 2, alpha divided by 2. And that's really where you have to multiply the p-value. It gets increased if you're looking at a two-tail test. Okay, so this is an important thing, knowing that not equal to is a two-tail test and the less than, greater than is a one-tail test when you're looking at the alpha level. Now, it's going to be important for you to really think about the direction you're going. Are you talking about the confidence level of a confidence interval, or are you talking about the confidence level of your hypothesis test, and which direction are you going? Are you going from interval to the hypothesis test, or the hypothesis test to the confidence interval, and how you're going to look at it? Now, the question I was on the discussion board, this had to do with the chapter 21 7C, and that question first asked us, so let's just put that up there real quick, chapter 21 7C. Starting, the question goes back and it's looking at a 98% confidence interval. So if you're looking at that confidence interval, we have confidence intervals always on be two-tail when you're talking about it. In the middle there, we're going to have our 98%, which means each tail now, we're going to split the leftover. 98, there's 2% left over, so we have 1% and 1%. Okay. Now, that was part A, was to make a 98% confidence interval. Part B was then to run a test, and the test was asking about a proportion less than 5%. So if we were to write out our null and alternate for that, we would have our null pi equal to 0.05. Our alternative pi is less than 0.05 because they were looking to go less than 5%. And you ran your hypothesis test on that. You should be able to look at the work for that. And part C asks you then, what is your level of significance? It's asking you what your alpha level would be. Now, a lot of people, they saw, okay, we're at 98% confidence interval, and the first thing you want to say is our alpha level would be 2%. The complement of the 98% confidence level. What you have to think about is the direction. Okay, our alternative is less than 5%, which means we are going to be looking at a one-tail test. We only care about the one tail. So this was going from a confidence interval and then doing the hypothesis test. Our alpha level that we'd be looking at, our level of significance, would only be, since we're looking at the alternative of less than, would be that left tail. So our alpha level, or our level of significance, 0.01 or 1%. Okay, so again, I told you it's important to think about, are you going from a confidence interval to a hypothesis test? And that's what we did here. So you had to think about it. Now, if we just said it's not equal to 5%, then it would be 2% because you'd be looking at both those tails at one time. But since it was just looking at the less than, we were just looking at the one tail. Okay? Now, this is not a problem from the book, but let's just say, okay, there's an athlete, and we want to do a test to make sure he's getting enough calories to keep up his weight with all the training that he's doing. So let's say we're on a hypothesis test to make sure he's not going under. We want to take his average calorie intake, and let's say mu equal to 3,000. That's what they're estimating his calorie intake needs to be, and we just want to test to make sure he's not going under. So we're looking at less than 3,000, and we are going to test that at a 0.05. So our alpha level is 0.05 in this case. Okay, so if we are looking at how this would look on the normal curve, where the tails would be, we would have our normal curve. Since it is less than, we're looking at the left tail test, and our alpha level of 0.05 is that area there. Okay. Now, if I ask you then to make me a confidence interval that fits this situation, okay, knowing that your alpha level is 0.05, a lot of people would jump into this and make a 95% confidence interval. This first test that we ran, we wanted a level of significance of 5%, and that had to be our alpha level in the reject area. Okay, so that made the 0.05 here. If I then ask you to make this same situation into a confidence level, we can't change that alpha level. That would change the probability of us rejecting it, which now that would affect the probability of getting one of our errors, a type 1 error. If we're not change this area, hey, that's going to change that probability. We don't want to do that. So if we ask you then to make a confidence interval for this, if I'm not giving you a specific confidence level, if I'm not saying, okay, make a 95% confidence level, you have to base it off of the alpha level of 0.05. So alpha level of 0.05 is in that tail, and that can't change. But since our confidence interval has to be 2 tails, our tails have to be equal. We're now going to take this, I'm going to use a different color here, take this, and we're going to make that other tail also 0.05. Now we're symmetric, okay? So we have 0.05 here, 0.05 here, or 5%, 5%, which now our confidence interval then, how big that has to be. 5%, 5% is 10%. You would make a 90% confidence interval. So our interval then would have to be 95% to fit this situation. And again, this is going from a test, hypothesis test, to the interval, but it's important to think about our alpha level there, our alternative and what side it's going to be on. Okay, and if it is a one-tail test, okay, if this was a two-tail test and we had that, okay, our alpha level is going to be 5% or the 0.05, that would already be split up automatically if it was a two-tail test. Okay, then all that would work out for us. If you looked at the normal curve, let's just look at that then real quick. Okay, let's just say we wanted our mu to be equal to 3,000, our alternative not equal to 3,000, and our alpha level is 0.05. So it's all the same, except it's not equal to this time. If we were then to draw our normal curve, we have left tail, right tail. We'd be splitting that right away. Alpha divided by 2, alpha divided by 2. So we're looking at 0.025, 0.025. And if I ask you to make a confidence interval for this situation, well, our confidence interval is alreit's set up. Okay, we don't need to add the other tail because both tails are already shown. Inside we have 95%. So it's an ugly 9, sorry. That 95% would be our confidence level for the interval. Okay, so what you need to think about, are you going from confidence interval to hypothesis test? Are you going from the hypothesis test to the interval? And it's very important you think about one-tail test or two-tail test. Think about the left tail, right tail, or if it's not equal to, it's going to be two-tail. Okay, so I hope that cleared some things up with alpha level and confidence level going from hypothesis test to intervals.